Hello friends, welcome to another video, and in this video we will discuss one more advanced coding question of TCS NQT. So this question is a similar question that I have already discussed if you have gone through that, where we had to find the maximum amount of gold coin that we can collect. So if you can remember, so there basically we had to find the maximum sub array with sum exactly equals to k, and here we have to find the maximum sub array, length of the maximum sub array with sum less than k. So this is the minor difference we have, but all the algorithm that we will be using is exactly same. Here also we will use sliding window, and that video also we had used sliding window. So this is just the same question, so you all have to pay very much attention. So try to understand this question, and this algorithm is also very popular, so try to learn it. Okay, so there are chances it could be repeated. So try to understand the question that we will discuss. And the code I will discuss here in Python, and I have made a separate video of same question with C++ also and Java also. So you can go there or whichever language you are good in. Okay, so try to pause the video and read the question. Okay, this is a bit lengthy question, so try to read it. So I hope all of you must have gone through the question. So if I can say about the question, so this is just this, the highlighted words you can see, this is just the conclusion. So we have been asked to, can you please find the length of the maximum continuous sequence of horses on which Bob can make a bet, and remember he will invest money less than k unit. So we had to find the length of the maximum sub array whose sum is less than k. This is the general question, but then also I will make you understand the question. So the question is like this: there is a person named Bob, and he is going to put money, put a bet on different horses, and the price of each horses is given. But he wants to put the bet on continuous horses. This is the condition, and money that he can invest is less than k, and he want to find the maximum, that we have to find the maximum length. So let me make you understand. So the input will be given like this. So the first line of input, so this will be number of horses or the length of the array, and this is k, that is this much amount Bob has, and he can only invest less than 100, means less than k. So up to 99 he can invest or he can spend. Okay, and he wants to make the length of the continuous sequence that we will see maximum. Okay, so it is like this. So these are all the horses, and these are the money on each horse. So we will start from here, or Bob will start from here, put a money on this, put a bet on this horse. So 30 rupees will be spent. Now still he has left with some money, so we will move forward, and suppose if he put a bet on this horse also, so now 70 rupees spent. Okay, but still he is left with some money, so again he will move forward and try to put a bet on this horse. But the moment he will do so, the amount of money will be 30 plus 40 plus 50, which is 120. Now if he will put bet on this horse, the money needed is 120, but he has only 100 rupees, basically 99 rupees, because he can spend only less than k. So he has 99 rupees, but here it is needed 120. It means he cannot put bet on this horse. Okay, because he wants to be continuous, so if he cannot put bet on this horse, he cannot move further also, because he will be running out of money. So if he will start from here, he can only go up to 2 horses. So this is one possibility. Now if he will start from second horse, suppose he will left the first horse and he will think to, okay, start from here, then he can go up to here, because the moment he will put bet on these 2 horses, 90 rupees will be over. And if he will try to move further, then he need 90 plus 20, 110. So this is not possible. So starting from here, if he will go, the length is 2. So this length we have to make maximum. So up till now, the maximum length or maximum number of horses that he can put bet is 2, and he want to maximize this. So let us see some more cases. So now he can start from third horse. So 50 plus 20 70, and plus 20 90. So still he can. So up till here 90 rupees over. Now the moment he will try to increase further or move to this horse, so 90 plus 10 100. So he has 100, but as I told you many a time, he can only spend up to 99. So he cannot put bet here. So if he will start from third horse, he can go up to 3 length or 3 horses. So as we want to be maximum, so 3 is greater than 2. So now the answer will be 3. Okay, so are you getting the pattern? So just we have to find in this way. We have to find continuous. So we will start from 1 and try to see where I can go. The moment money will be exhausted, it's over. We will find the length, how many horses he covered. Next we will start from 2, then go on, or 3, then go on, and in this way. So for this question, you can find that the maximum number of horses, continuous horses, that he can put bet on is 3. You can try all other cases. Okay. So I hope you understand the question. So how we will solve this? So this will be solved using an algorithm called sliding window. So I hope you have understood this question. Now how we will use sliding window? So sliding window says that, so suppose he started from here. So this is another example I have taken. So in this case he has money 12. So suppose he started from 2. So he can easily go 2 plus 1 3, 3 plus 3 9, still he has money. 9 plus 4, okay, 2 plus 1 3, 3 plus 3 6, sorry, 2 plus 1 3, 3 plus 3 6, and 6 plus 4 10. So still he can be at that. So if he go up till here, 10 rupees has been spent. But the moment he will move further, 10 plus 4 will be 14. So he cannot move further. So now what we will do, up till here what is length? 4. So we will store it. That maximum up till here is 4. Now we know that if you start from here, so we cannot move further. Because the moment we will try to move further, our money is also, or Bob's money is already been spent. So he cannot move further. So what we have to do? We have to exclude this case. Now this is over. Now we will try to move from second one and then calculate how far we can go. If that will also be over, then we will start with 3 and move on. So this is the basic idea. Okay. So how sliding window helps us here? So sliding window works like this. So it says that if you have calculated the sum from here up to here, suppose from horse 1 up to horse 4, and you have now completed. And now if you want to calculate from 2, so again we have to find the sum. So from here we have already find the sums, that 2 plus 1 3, 3 plus 3 6, 6 plus 4 10. And now again we will start from here. So we need 2 loop in general case. So now what we want, that within one iteration we have to do this. So from here to here we have already found the sum, and now we want the sum from here and then move on. So it says that if you have already calculated sum from here to here, and now you want to find the sum from here to here, so there is no need to recalculate, because I have already calculated. So if we have sum from here to here, here to here, if you have the sum, can we not also have the sum from here to here? Yes, because this is a part of this one. So if from first horse to fourth horse the sum is 10, and now if I ask you, can you not find the sum from second horse to fourth horse? Yes, it is very simple. Whatever sum we have, just exclude this one, minus it. The moment you will subtract the sum of this horse, we will get the sum from here to here. So this is sliding window. Now this is one window, the line you are seeing in red, and we have slided, we slide this window to here. So can you see this is sliding? So this is called sliding window algorithm. We are trying to slide the window And this will help us. Why? Because no need to recalculate the sum. So it says that if you have the sum from 1 horse to 4th horse, it means we also have sum from 2nd horse to 4th horse. Just from the total sum, remove this one, 1st horse. Then we will get from here to here. So the same thing we have done. So up to from 1st horse to 4th horse, the sum is 10. The moment we will exclude this sum of 1st horse, which was 2. So 10 minus 2, which is 8. So this is the sum from 2nd horse to 4th. 4 plus 3, 7 plus 1, 8. So no need to recalculate. Now from here to here, we already got the sum, 8. Now we will just add this one. And we will check 8 plus 4, 12. So this cannot be, because we want less than 12. So this cannot be. So up till here the length will be 3. Similarly, now we will slide our window. Now from here we will try to move. So this is the algorithm. Okay, this is called sliding window. So now try to see the code. So the code we will do simply. This is the Python code, and I've already discussed the C++ and Java one also. So the idea is simple. So the first we will take the input n and k. Second line we will take all the price of the horses. Now this is one variable sum1, in which we will keep the sum of all the horses. This is count. We will keep what is the length of the continuous subarray. And this is max length. This we will find for the answer. So at last we want the maximum length of the continuous subarray. So this we will store here. Now one by one for loop is there. One by one we will try to add the price of the horse into sum1. And if it is still less than k, we will keep on moving. Okay, so it is like this. So sum1 is initially 0, count is 0, max length is 0. We will start from here and we will add it to sum1. So sum1 now will become 30. And then we will check. So first horse we put the weight, and now it is 30 is less than 100. It's obvious. So it means we can put bet on this horse. I have the money. So the length is 1. So count will be 1. And now we will check, is this count the maximum? So this line is that one. At last we will see whether this count is maximum or not. So maximum is 0 and this count is greater than max length. So now max length will be 1. Now we will try with next horse, and we will check, okay, if I try to add this horse, still I have money or not? So 30 plus 40 is 70. So still Bob has money. So again he will also include this horse. So now sum becomes 70. Okay, now length count become 2. So 2 horses here, and maximum is, so since this count is more than max, so that will be new max. So now 2. Okay, so are you getting this? Just we are iterating through the loop and trying to add another horse. And if it is still less than k, we will increase the count. Sorry. So I hope you understand. Now see, this is very important for all of you to understand. This question is very popular and you can get similar question also in the future. So try to understand it. Okay, now again we will move forward and we will see, can I include this horse also? So 30 plus 40 is already 70, but moment I will include this, so 70 plus 50 will be 120. So I do not have that much money, so I cannot include this. So in that case what we will do, if you can see the code, so this if was, if the sum is still less than k, so this if was working. The moment it is not less than k, then what we will do, we will try to remove the previous one. So that's why you can see in sum1 I'm trying to remove some part and trying to add some part. So what is this? This is the sliding window we are using. So sliding window, what does it tells? So starting from here, if you cannot go further, so try to remove this one, because now we will start from here, second one. So try to exclude this, because there is no need. From here we have calculated our answer. From first horse we have seen that we can go up to here only. So now we will start with second horse. So we have to remove the sum of this one, because now we want sum from here. So same thing we are doing in the code. We are trying to remove the last value and add the current one. So I minus count, why this is? Because I minus count will give which element we have to remove. It is like this. So now when we try to add this horse, we do not have enough money. So we want to remove this one. So remove this one means A of I minus count. So I is here 2. 2 minus count. Count is here 2. 2 minus 2, 0. So can you see this? 2 minus 2 is 0. So A 0, which is this one. So we will remove this from the sum. So now our sum will be 40. Okay. So now our sum has become 40. Let me delete some part. So now our sum has become 40. Because see, now we have started from here. So we already got the sum, and now we will add this also. Okay. So you can see here, I have removed this part and add new one. So now I want to calculate answer from second horse. So now 40 plus 50 is 90. 90, and count is still 2. So from here 2 is there. So 2, and max length is also 2. Now we will try to move to next horse, and we'll see, okay, can I include this? So 40 plus 50 is 90. 90 plus 20 is 110. So I cannot include, because I will run out of money. So I cannot include this one. It means I have to remove last one, because from here I can go up till here only. So no, I cannot move further. So if I cannot, from here, this is the possible length. So now I will start from here. So I have to remove this. So again I will remove this one, this 40. So now our new sum will be minus 40. 90 minus 40, which is 50. And I have included this one, 20 also. Okay. So plus 20. So 70. So now this was our new window. Now this is our new window. So again and again we are trying from each horse as a starting point. So now our new window is 50 and 20, which is 70. Count is also 2. Max length is also 2. Now we will see, can I include this? So we will check, okay, up till here sum is 70. The moment I include 20, so 70 plus 20, 90, which is less than k. So it says yes, you can go ahead. So I will include this. The moment I will include this, you can see count will be increased. Count equals to count plus 1, and sum will be increased also. So now count will be 3, and sum also will be 90, because I have included this. And now count is 3, which is greater than max. So this will be our new max, 3. Okay. So can you see it? We are just moving ahead, sliding the window. So here we have done. Now the moment I will try to include 10 also, we will run out of money. So 50 plus 20, 70 plus 20, 90 plus 10, 100. But we want up to 99 only, because it has to be less than k. So I cannot include this. So I have to remove this. So from here I can go up till here only. So now we don't want a starting point to be here. Now we want starting point from here. So we will remove this. Again we will add this. So in this way we will keep on moving. So I hope it is clear. There is nothing much in it. So just you have to understand the algorithm. So let me try a few test cases, then we will at last recap. Okay. So try a few. 30, 100. Sorry. 10, 100. 10, 100. you can see our maximum length possible is 3. So try some more. Let me give some simple one. So 1 1 1 1 1 5 1 1 1 1 2 3 4 5 6 7 8 9 10. Okay, in this case maximum length possible is 4. That is from here up to here, one possibility. This also can be another, but maximum is 4. Okay, so in this way you can try your own test case. I will put this code in the comment section. And so at last, let us recap. So idea is simple. We will try. So these are the just input. This is someone, that is will keep the amount up till certain length. This is count, which is the length count, and this is maximum length possible. So we started one by one, and we see that okay, if I include this amount in our sum, still we are less than k. So if it is yes, we are less than k, it means we can include that amount and the count will be increased. The moment it is not so, that it is not less than k, then what we will do? We will exclude the initial one, that is starting point, and we'll add the current one. And then we will see whatever count you have, it is greater than max, it means this count will be our new max. Now why this sum 1 not equals to 0? So this was just given to compensate for our initial case. So suppose initially there is some amount, so first element is only higher than k. So in that case this test case is given, because in that case suppose we have only one horse and I have money 10 rupees and the price of that horse is 100 rupees. So I cannot put bet on it, but I cannot remove any part because this is the first element itself. So that's why this condition is given. Okay, so I hope it is clear, and this is all code about, and this is all I have made you understand. So just we have to keep sliding the window. So just we will see, okay, if I start from here I can go somewhere. The moment I will stop, so now there is no need. So I have done this case. Now we have to start from second one, then go up to certain case, done, then start from third one, go up to certain, and see which is maximum. So okay, so I hope it is clear, and try to go through the video again if you do not understand, and if you have any doubt in any part of the code, you can put in the comment section, you can ask it there. So this is all from my side, and thank you guys, take care.